All right, so Foundations of Math 30, section 3.1 is what we're going to study today. Launching off a new chapter here. It's called Sets and Set Notation is what this section is called. And in your textbook, this is what it looks like. And so we're going to be talking about, basically we're going to be going through a bunch of definitions right here, so we're all on the same page for what's to come in the chapter. So, I guess in this Investigate the Math here, it says this: Jasmine is studying the provinces and territories of Canada. She has decided to categorize the provinces and territories using sets. Okay, so set, you'll see in your textbook that they have bold-faced terms, they have highlighted terms. And so what I want you to do is I want you to just copy down this definition, or you can summarize it if you want. But let's talk about what a set is. Okay, so I'm just going to paste that over here. Make that a bit bigger so you can see it. Okay. A set of something, and you know intuitively what a set is, okay? Like it's a grouping of different things, but mathematically the definitions might sound a bit different than what you would intuitively think. So that's why we're going to go over the definition. A set is a collection of distinguishable. Now this word means that each item is different, okay? So we're not talking about a bunch of identical objects. We're talking about distinguishable objects, so ones that are different from each other. And the example here is the set of whole numbers. Okay, and we would write in one set of notation, the set of whole numbers with a capital W equals these kind of funny brackets, the braces here. And then 0 is where the whole number set starts, comma, 1, 2, 3. And then the 3 dots, of course, means this pattern continues on indefinitely. So this is a set of numbers, and this is the whole number set. Okay, so collection of distinguishable objects. Now, an element. Okay, if we take a look at what an element is one of those objects in the set. All right, so we'll clip this one, element, to bring that into our notes. An element is an object in a set. Okay, so again, you have a set of numbers, or a set of items, a set of people, a set of animals, a set of colors. And an element is one of the objects in the set. So an object in a set. All right, the universal set. So we're taking a look at the provinces, right? And we'll get into kind of more details here. The provinces and territories, everything together, the whole shebang, the whole kit and caboodle, and what other sort of ancient phrases we can use there. But the universal set is really the set of all elements. The set of all elements. I'm going to see if I can just copy and paste this way. It might be easier than clipping. Oh, beautiful. All right. So an element. Whoa. Oh, okay, that's why it didn't work. Wow, an element. Let's get rid of that. Technology is so awesome. Okay, so that doesn't work. I have to clip that. You guys having fun? The universal set is the set of all elements under consideration for a particular context. Right? So it basically means every element, doesn't matter what set that element belongs to, or what sort of subset the element belongs to, but if we're talking about, and this example is digits, okay, we have digits, these digits right here. Now, within that kind of overarching set, or that universal set, we would have subsets, right? We would have, odd numbers. 1, 3, 5, 7, 9. So inside the universal set, and think universal, the whole universe, encompassing everything, we would have subsets. Okay. Okay. So all the elements under consideration for a particular context, also called sample space. Now, if you remember the phrase sample space from years past, that's sort of a similar thing. So as I mentioned here, we do have this subset right here. The subset, okay, as I mentioned before, it's the a set that's basically within the universal set. So a set whose elements all belong to another set. So if we're talking about the universal set, the odd numbers would be a subset. So that understanding that, I think, is easy. You know what a subset is. Just take note here that there's some special notation, and this is not OCD, okay? You're not obsessive compulsive. This is O is a subset of D, okay? So you have your letter there, and it's just basically kind of like a sideways U or kind of a flattened C or something. But it's a special symbol that means subset, right? And so they did talk about the odd numbers, just like I talked about earlier, and O is a subset of D. Okay, OCD. And finally, on this first page, they talk about complement. Okay, isn't that very nice of them to give us a compliment on this page? Yes, yeah, thank you. You can laugh. That was a joke. Sort of a, as I know, it's a kind of a math teacher joke. It's not really like a fun student joke, but anyways, here's your compliment for the day. The complement in math means this: all elements of a universal set that do not belong to a subset. So for example, if we talk about everything that does not belong to the subset of odd numbers, that means everything else that would be left over. So if we go back to our universal set, everything that's not odd would be these numbers right here. Okay? So, and this is not necessarily the subset E, like for even numbers, but this is the subset O prime. And this little tick mark right here is like a prime symbol. It's not an apostrophe, okay? It's sort of like the same sort of symbol you would use for like maybe feet, right? It's a prime symbol. We use it a lot in calculus, okay? Prime. But anyways, that's the symbol, and that means everything that is not O. Okay, the complement. If you think about the term, something that's complementary, right? Yes, a complementary thing is like something that's free, but if you think about that, is very complementary to another thing. That means it goes alongside. It's not the same, but it's something that sort of goes along with. And in a sense, you know, if we think about a subset of numbers, the thing that comes alongside would be everything else that surrounds it, right? I don't know if that helps, but that's how you can remember that. So all elements that do not belong to a subset. That's what complement is. Okay. So if we had, if the universal set in here was, you know, boys and girls and teacher, because I'm not one of those, I guess. And let's say we had some mice here that we can't see. That would be terrible. But let's say we had some animals in here, right? So everything that is not, okay, like the boys, okay, the subset boys, everything that is the complement of boys would be all the other sets that I mentioned. The girls, okay, me, the teacher, and the mice. Okay? So it's different than saying the complement of the boys is the girls. No, if the universal set encompasses some other sets, then it's all of those other sets. You get it? Yeah? Am I saying this too many times? You guys all get it? Okay, show me a 0 to 5 on the scale of how much you understand this. So 0 is, I don't get this at all. This is way too tough for me. And 5 is, I get this, so I could probably teach it, Mr. MathWell, and probably do better than you. Okay, so where are you in that continuum? Okay. All right. Okay, good. I'm seeing a lot of fingers. That's good. When students flip me fingers. That's sometimes it's not a good thing, but in this case, it's a great thing. Okay. All right. So if we go back to the textbook here, all right, let's see. List the elements of the universal set for Canadian provinces and territories. Well, if we look at this diagram here, you understand that in Canada we have some provinces and we have some territories, right? Okay, Northwest Territories, right? That's a territory. Saskatchewan, Alberta, BC, those are provinces. So we could pick out some territories and we could pick out some provinces to make the universal set. Everything that's here is the universal set. The subset of Western provinces here, okay? Western provinces and territories would be, you know, everything that's sort of the west of the middle, so to the left of the middle over here. Now, do you guys know about Venn diagrams? I think they should have been introduced to you before in previous classes, but this is a Venn diagram. Do you guys recognize this? Okay. So in a Venn diagram, we have usually a rectangle of some sort that encompasses the universal set. So everything would be in sort of one region of space. And inside that, you would have different subsets, and they're usually circles or ovals or something like that. And so inside all of the Canadian provinces and territories, symbolized by C here, it looks like, we have some of the western provinces and territories. All right? This would be a subset. The elements inside that, depending on what they're considering western, but, Nunavut, Manitoba, Saskatchewan, Northwest Territories, Alberta, British Columbia, Yukon. So everything that's kind of west, that would be inside the circle, let's say. And there would be other circles, and even some circles could overlap, as we'll talk more about Venn diagrams later. All right, so a couple more that we'll want to talk about here. The empty set. Oh, what is the empty set? If you're a football fan, I don't know if you know football, the empty set, the empty backfield, the empty set. It's when there is nothing in the area. So the empty set here is a set that has no elements in it. Okay? So if we go back to let's go back to the Canadian provinces and territories example. Okay? The subset of American states within that would be empty. There's nothing, right? Because that's not even in the same ballpark, right? Or if we go back to our classroom example, boys, girls, teacher, mice, okay, the subset of giraffes, or there's nothing in there, or the subset of, African Sahara animals is empty. We don't have any of those that I know of. Unless you're counting pictures of the wall, I'm sure. So an empty set has no elements in it. Set with no elements in it. Okay? Questions? You guys are okay? Alright, so one more. Disjoint. Disjoint sets. If something is disjointed, right, that means it's separate, it's pulled apart. Okay, if you separate your shoulder is been disjointed, let's say. It's pulled apart. So this would be, the disjoint sets would be two sets that, or two or more, that have no elements in common. Okay? So if we're talking about, the subset of mice and boys, no comments, girls, here on this. This is not a place for you to make jokes. But those would not overlap at all, right? Those two sets would be completely different. You wouldn't find any person or animal that would exist in both. Okay, now if I said male and mice, we'd have an overlap there, because there are male mice, right? But if we had boys in the class and mice, those are two separate sets. They do not overlap at all. Thank you, girls, for being restrained there. Appreciate that. Boys, you should appreciate that too. Okay, so disjoint. Two or more sets having no elements in common. Alright, so we move on to notation here. This is a bit of a summary of notation. And your textbook is good for having little summaries, okay? Key points and stuff, I believe, here too. So if we go down here, there's some good explanations of the examples. And let's see what's at the end of the section. Yeah, right here, in summary, okay? These are awesome. The in summary are really, really good. So when you're studying or looking over your notes or preparing for a quiz or an exam, these in summaries are quite valuable. It's literally a summary of all the important stuff that we would have done. So back to the notation, and I'll go through this real quickly. Remember, we're using these kind of funny brackets. You might have to practice making those, the braces here, but that's typically the notation we use to enclose elements in a set. This one right here, remember, that's a subset, okay? And this little notation there, that prime symbol, that means the complement. An empty set, okay, can be written a couple different ways. An empty set, you can have the braces with nothing in it, literally. That's empty set. Or you could write sort of this zero with the line through it. That means as an empty set. Okay? Questions? All right. All right. Let's do this example here. Okay. Just for some more definitions here, let's do infinite and finite sets here. All right. So in a finite set, okay, there's two things we want to look at. One is called the finite set, which is basically all that means is that there is a countable number of elements in the finite set, right? Finite. The infinite set is, of course, opposite of finite, and it means a set with an infinite number of elements. Okay, so we don't work a whole lot with infinite sets, but at times we do, and that's what we mean. Okay, so if we're talking about the natural numbers or the whole numbers or the integers, those are infinite sets because remember those little dots there, right? That means the pattern continues on indefinitely or forever or infinitely. So that's just a little difference between finite and infinite sets. All right, describing relationships between sets. Okay, I want to talk a little bit more about Venn diagrams here. In this example 3, Alden and Connie rescue homeless animals and advertise in the local newspaper to find homes for them. They're setting up a web page to help them advertise the animals. Okay, so it says design a way to organize the animals on the web page, represent your organization using Venn diagrams. So how can we, make use of this and draw a Venn diagram with it? They're going to ask us to name any disjoint sets and to show subsets, okay, of these things. So one of the things you could do, and again, I'll just kind of go over some of the suggested answers here. But what this Connie did was she said, okay, there's a universal set A which includes all of the animals that we have, okay, and inside that universal set we have warm-blooded animals and cold-blooded animals, okay. So there's two types of animals there, warm-blooded and cold-blooded. The warm-blooded animals include dogs, cats, rabbits, ferrets, parrots, lovebirds, macaws. The cold-blooded iguanas and snakes. I don't know if you noticed or not, but you can also separate this set into two sets, and so that's what they did. Mammals and birds. So inside the set of warm-blooded animals, it's split into two. And I just kind of, the bottom line is, so I kind of want to get to this Venn diagram. This is what's important. I want you to be able to see this and understand what they're doing. So the A is the universal set, right? All of the animals. W is warm-blooded animals. And so inside this W kind of oval here are the list of all of the animals that are warm-blooded. Over here, this is the cold-blooded, okay, subset. Inside the warm-blooded subset, there are two more subsets, mammals and birds. Okay, so this is a way to organize all of this. Okay, and so you can see the categories all nice and neatly. You can see what the subsets are and all sorts of things. So disjoint sets. Okay, disjoint sets would be W and C would be disjoint. They're totally separate. M and B would be disjoint as well, B and C, M and C, and so on, right? So all the ones that don't have any overlap. Would W and M be disjoint sets? What about W and M? Inside W is dogs, rabbits, ferrets, cats, parrots, lovebirds, macaws. Inside M is dogs, rabbits, ferrets, cats. Do they have any elements that are in common? Yes, they do. So they are not disjoint. If one subset is inside another subset, they are not disjoint. And of course, there's other ways you could disaggregate the data or separate. But that's basically the what I want you to get through there. Okay, so we have one more definition that I want to go over with you: mutually exclusive. Okay, so they're kind of like disjoint sets, but if we have two things or two events or two things that happen that are that cannot happen at the same time, okay, that they can't be simultaneous, then they would be called mutually exclusive. So two or more events that cannot occur at the same time. So in our previous example, let's say we said selecting a cold-blooded animal and a bird. There isn't one animal that fits both of those, so those would be two separate events. All right? So they cannot occur at the same time. Okay? Going into the room and going out of the room. Being in Mexico and in Canada at the same time. They're mutually exclusive. It's either one or the other. Okay? Questions? All right. Okay, so we'll let you just go over the summary here a little bit. I'm just going to leave that up on the screen for a bit for you to read over. Some of the things that we didn't really cover here yet would be this this right here, the little n. Okay, let me just zoom in on this a bit here. Okay, so this little n here, this literally means the number of elements in set A. That's what n bracket A means. Okay, little n. So little n bracket A is the number of elements in A. And so you see these little n's all over the place. It means the actual literal number of elements. You're not listing the elements. You're just counting them. Okay. And what about this A or B thing? Okay. What about A or B? Well, and we'll talk more about this in another lesson. Okay. But if there's a subset A and a subset B, then you're basically counting all the items in either one. Okay. In A or in B, and you count them all together. All right. And so here's just a couple things. I'll let you kind of work through the assignment, and if you have questions about this tomorrow, you can ask me. But I won't spend too much time on this now. So we'll back it off, and that's the lesson for today. I'll give you your homework here shortly. Do any of you have any final questions? Yeah, here's the assignment. 1, 2, 4, and 13, section 3.1.